I'm Pete Zielinski with Additive Manufacturing.media.
I'm Stephanie Hendrickson, also with Additive Manufacturing.media.
Manufacturers have changed course this year in response to the COVID-19 crisis. Additive manufacturing is a big part of the story. So we've changed course too. For now, once a week or so, we're going to check in with a video like this to let you know what we're seeing. Stephanie, what are you seeing this week?
So Pete, you said change course, and I feel like this week especially, that's something that we're seeing in the manufacturing space. We're seeing 3D printing companies and more traditional manufacturers really pivot to production. They're focused on making PPE, making ventilators, making other items to deal with this coronavirus situation.
Yeah, so pivot to production. That's right. So production manufacturers, like it's the maker community, kind of dove into this crisis right away, including hobbyist users of 3D printing, producing PPE, particularly face shields, and kind of demonstrated one of the real strengths of 3D printing, which it is the manufacturing process with the shortest lead time, able to react the fastest. But that response has been different in different regions of the country. We kind of talked about that a little bit last week. Different levels of connectedness to hospitals, different levels of effectiveness meeting the hospital's needs. Also, arithmetic works against these folks. These small sort of desktop FDM printers, they're really not made for fast production, for scale production. Some maker groups have responded to this just with raw numbers, like bringing together coalitions of lots of 3D printer users. And I've talked to a lot of these groups, a lot of representatives of these groups, really too many to mention. Here's a photo that came late yesterday. This is from James Hoffman. He's a STEM teacher at Newton High School in Newton, New Jersey, and he's leading a group of about 40 makers and their 3D printers. The effort is called PPE Made in the USA, and it all started with an appeal from Rutgers, New Jersey Medical School. Actually, now there are 7 different school systems involved in the effort. Another example, here's a couple of photos. Shashi Jain in the Portland, Oregon area. His day job is working for Intel. He's organized a network in that area of about 150 different 3D printers. They have volunteers now, this group, delivering PPE to hospitals in the area. The photo you're looking at actually shows a pharmacy, but same principle. You get the idea. Go to Makerforce.org to learn more about their effort. So a couple examples there, and what these really show is the heart, among other things, just the heart to get involved and serve and help. These are like the 3D printing first responders. But we're seeing now what comes next, right? We're seeing industrial production scale 3D printing, additive manufacturing coming online, and the picture's shifting. The picture's clarifying a little bit. I think you have an example of that, Stephanie. Am I right?
Yeah, and so just to kind of to pivot off of what you just said about the whole maker movement, I sat in on a 3D Heals webinar earlier this week where there were medical professionals, there were manufacturing people in this webinar talking about all these different issues, and this is something that came up. Setting aside the materials and potential porosity with items that are made with an FDM printer, the numbers kind of don't work in your favor. You're not going to be able to produce tons and tons of face shields or whatever other equipment there might be. So there are other manufacturing techniques that are going to be more productive. There are even other 3D printing techniques that are going to be more productive. So the example that I want to talk about today is a company called Rapid Application Group. They're in Tulsa, Oklahoma. And they are a aerospace manufacturer that is now making face shields and making masks, respirator masks. But they are using equipment from 3D Systems and EOS. These are selective laser sintering SLS printers. So it's a powder bed process. And the nature of that process is such that you can nest your parts inside the build platform, and you can nest them vertically as well as in the X and Y. And so they're saying that they're going to be able to print something like 300 of of these respirator masks in a day, which is almost 2,000 in a week. So the scale there is much, much higher than what you're going to get with an FDM printer. Um, but even they're also looking at mold tooling. They're thinking about ways to take this production even higher. I think they're a really interesting case though, because they are manufacturing items that are PPE, but talking to them, it's not a really simple process. It's not you just get the approved file and you use the right material and like that's all that it is. They've put a lot of work into designing this respirator. It's supposed to be an N95 alternative. When I first talked to them last Thursday, they were not seeking approval for this to be used in a clinical setting, so doctors actually treating COVID-19 patients. Instead, they were really focused on first responders. They wanted to get these masks out to EMTs, to medical support staff. They've sort of changed direction now, and they do want to seek that clinical approval, and they've developed a design that might get there. So it's two different laser sintered pieces that fit together, and then you're able to put an N95 filter into the mask. And so one existing filter could potentially be used between 4 and 6 times in a mask like this. So you're getting a lot more use out of the existing material. But they are also going through the fit testing process. So they have actually used a local health clinic to make sure that the mask seals and that it's going to be effective in protecting people the way that they think it will be. And the material that they're using is a nylon material. It's biocompatible. It's safe for contact against your skin. It's actually, in the design that they actually have sort of a gutter in the mask where you can put a piece of food grade silicone tubing. So like that's what's actually forming the seal around the mask. It's not directly nylon onto your skin. But all that to say, like there's a lot of different things that they had to think about. And I think that Rapid Application Group is actually a good example of a company kind of going above and beyond, to the point that their CEO posted a video on LinkedIn where he put the mask on and ran a mile on the treadmill to like test the airflow. The other thing that I want to point out here is like this is an industrial 3D printing company. They are an aerospace manufacturer. They know how to work with regulations and standards and this kind of thing. And even they are saying, we're not a medical company. We don't have all the equipment that we need to do this exactly the right way. So just for example, the material that they're using is something you can put in an autoclave, which is really important if it's going into a hospital. But they don't have an autoclave. So what they're doing is they've taken their mechanical testing lab, cleared all the equipment out of there, and they're doing a bleach dipping process to make sure these are clean, but they're not sanitized. So when they go into a medical facility like a hospital, for instance, they're going to need to go through that autoclaving process. So even a company that is set up for 3D printing for production in another end market, in another specialty, is not going to be able to make that pivot super seamlessly. There are some things that they've had to learn, some things they've had to figure out. And, there are standards and protocols in place that we have to follow.
So something I kind of picked up on in there is you said, in spite of the fact that they've got a production volume 3D printing process, they're looking at molding maybe as a possibility to get the quantities that they need. The big story in production right now in the COVID-19 crisis is ventilators. We're seeing manufacturers across the country, around the world, actually shifting to production of ventilator components in this race to try to produce enough ventilators to keep up with the quantity of sufferers we expect to see as this illness surges. Additive manufacturing plays a role here, but in many cases, that role is bridge production. Here's an example. Linear AMS. We've written about Linear in various occasions on additivemanufacturing.media. A user of production quantity 3D printing. They have both metal and polymer 3D printing. In polymer, they use HP's multi-jet fusion process, again, capable of production quantities, depending on how you define production, through their additive manufacturing manufacturing, but they're using additive now for initial production, get parts out there, get parts validated. But linear AMS is also a molder, injection molder, and they're ramping up to do high production injection molding of these components that they're producing. Additive manufacturing as a scale production option, it's best suited for parts that are designed for additive, designed to take advantage of the freedoms that additive brings, the new possibilities additive brings. And of course, the ventilators don't fit that description. The ventilators were made for conventional production processes. We're just trying to produce more of the same kind of ventilators we already have. And so those conventional processes are what really are the strongest hope for providing the production quantities that we need. It took a little longer for conventional production to get fully engaged, but maybe now we're seeing this moment where additive manufacturing, which was the explosive sprinter right out of the gate, is handing off the baton to the distance runner, conventional manufacturing, that's going to take us all the way to the rest of the solution. Stephanie, what else are you seeing?
So something else that's kind of come up recently, and I think it could be an example of that kind of bridge production like you're talking about, is testing swabs. So these are the nasal swabs that your medical provider would use to test you to see if you have COVID-19. Under normal circumstances, they're not used that frequently, but they might be used to test for just the regular flu. And we're facing a shortage of those right now. That's part of the one of the contributing factors to the lack of testing is just the lack of swabs. And as I understand it, the main manufacturer of the swabs that are typically used is located in northern Italy, so an area of the world that's been particularly hard hit by this pandemic. And so something that I just recently learned about this week is that there are a number of 3D printing companies. They all use DLP technology, the ones that I'm aware of. So Carbon, Formlabs, Origin are looking at 3D printing these test swabs. I don't have all the information about that right now, but I'm hoping that next week I'll be able to share a more thorough update about what's going on there. Pete, what else do you have today?
Maybe one other little thing, not so little. So we talked about how one of the consequences of sort of 3D printing's organic community level response to this is that some of the hospitals in more active 3D printing regions have an advantage in this. So like what region do you think would have the very best advantage potentially? Do you have a guess?
Oh, that's a difficult guess. I would probably say like the Boston area, like around
That's
MIT.
good guess. Good guess. So here's a picture of first responders in Pflugerville, Texas,
Oh, wow.
benefiting from 3D printing. So this is the Austin area, which is a center, another center like Boston, of additive manufacturing activity in the U.S. We held our most recent additive manufacturing conference in Austin. Essentium, located in the Austin area, they make this fast production speed FDM printer, this additive manufacturing system. And Essentium is using it to print masks that are aimed at first responders. Essentium's also seeking FDA approval to allow these masks to be used as surgical masks. But the first responder inclusion is a really important point. It's not just hospitals that are in need of PPE. It's not just hospitals that potentially could suffer from a PPE shortage. So the Pflugerville Police Department got the first order. I learned a little bit about this mask from Nirup Nagabandi, who is an engineer with Essentium. The mask is like a frame, and it holds a disposable filter media over it, and Essentium with each mask provides a supply of this filter media. They're getting ready to go into scale production of these masks. They expect to make 5,000 of them per week. First responders who are interested in getting an order of these, first responder organizations, you can contact Essentium directly.
So a couple of things to respond there, just very quickly. I think the first responder point is a great one, and I'm hearing about other facilities like, say, hospice and nursing homes, not to mention, food service and other industries where
Yeah.
people are in need of PPE, and it doesn't necessarily have to be, it doesn't have to be surgical grade, it doesn't have to be suitable for a clinical setting, but something like a face shield can be really really useful, or a mask like what you're describing. Another thing, and this came up in the 3D Heals webinar, is that a lot of these 3D printing efforts are extremely local. So the Pflugerville situation, any place where there's kind of a concentration of 3D printing enthusiasts or experts. One of the things that came out of that webinar was, make sure that there's a need before you start printing things, and find out what that need is. And so people, the experts that were talking in that video, we're encouraging people to, reach out to your local healthcare professional, reach out to your local hospital. I think that is going to be the biggest win for 3D printing in this situation. It's local, it's fast, it's flexible. It's maybe not going to make huge quantities, but there can be needs that are really immediate and really local, where 3D printing could make a big difference. So that's about all the time that we have this week. We've talked about some different resources that we will link in the show notes below. You can find more information on our website, additivemanufacturing.media, as well as lots of other content. We're trying to keep up with what's going on in additive manufacturing and 3D printing, including but also beyond the coronavirus situation.
We're part of Gardner Business Media, which is a media company focused on manufacturing. So, we cover additive, machining, molding, other sectors, other manufacturing technologies. The whole company right now is compiling stories, writing stories about the response to COVID-19 from within different manufacturing sectors and the way that it's affecting different manufacturing sectors. We have compiled all of that coverage throughout manufacturing, throughout Gardner Business Media, into one collection, updated daily, COVID-19's effect on manufacturing and the response from manufacturing to the crisis. And you can find a link to that whole collection at our website, additivemanufacturing.media. Stay healthy.